Hello, my name is Howard Winston. I teach physics and engineering at the Waterbury campus. I'm also an academic advisor for physics and engineering students. I had a long research and development career in industry. Now I teach full-time at UConn. My goal is to pass along my knowledge and skills to you, the next generation of scientists and engineers. This presentation will focus on opportunities to start programs of study in physics at Waterbury. Let's get started. The physics department is part of the College of Liberal Arts and Sciences at the University of Connecticut. Physics as a discipline is really the most fundamental of all the sciences. So physicists will study the universe at its most fundamental level. Physicists are interested in the interaction of matter and energy and the conversion of matter into energy and how energy can then also be converted back into matter. This all occurs in a framework of space and time, and according to Einstein's general theory of relativity, space and time itself are very dynamic quantities, and they in turn interact with matter and with energy. And so in your study of physics, you'll learn to describe really how reality works with these four basic concepts. Because physics is really at the foundation of science and engineering, earning a physics degree gives you a lot of insight and a lot of opportunity to go into many other areas. You really have the fundamentals to go wherever your imagination and your interests take you. So you may know physics is at the bottom here, but it's the foundation. And chemistry is really based on the application of physics principles, how particles interact, and taking that understanding and building models of atoms and molecules where you now have systems of particles interacting. But the basic fundamental interactions that we study in chemistry really can be derived from the basic fundamentals of particle physics. Now, chemistry itself, as you know, is fundamental, is the foundation for understanding biology. So biochemistry explains metabolism and how living systems work. And so you can think of biology as sort of sitting on top of the principles of chemistry, which, as I said, in turn are based on the principles of physics. Now, the human brain is an organ in a biological system. And so in principle, how we think, our minds, that is cognitive psychology, can be understood in terms of how the brain functions and what the brain's anatomy is. And again, that shows you that even understanding who we are at a basic level in terms of our minds and our psychology can be traced back through biology and chemistry down to physics. The applications of all this scientific knowledge, of course, are immense. In chemistry, you could become a chemical engineer, and that's abbreviated CHEG in the Department of Engineering at UConn. So you could become a CHEG major. You'd have to understand chemistry before you could apply it in terms of chemical engineering. If you're interested in engineering or the application of science, as a biologist, you could apply your scientific knowledge to BME or biomedical engineering. So perhaps you want to develop new medical instruments. You have to base that on an understanding of how living things work. And of course, who knows where computer science technology will go in the future? It evolves very rapidly. I'm sure you've heard of artificial intelligence. And there are subfields or disciplines in AI, artificial intelligence, which take a lot of insight from cognitive psychology. They're really trying to reproduce, both in software and hardware, aspects of how the human brain works and therefore how the human mind works. But as you can see here, physics is at the root of all of this understanding and all of this application. I'm just showing 4 physics courses here, or 4 topics in physics that you would be taking as a physics major. There are many more. For example, plenty of electives in astronomy and other areas of physics. Solid state physics is another example. But generally speaking, you'll be studying mechanics, the physics of mechanical systems. You'll be taking courses in electricity and magnetism or electromagnetism, understanding things like how electricity is generated and how power systems work. You'll be understanding or taking courses in thermodynamics. And this is where you're really beginning to understand how heat and work combined can be used to create all kinds of very interesting engineering applications, things like heat engines, namely how your car engine works, that's able to take chemical potential energy and convert that into mechanical energy, and the science of understanding how that works and how efficient you could make that is in thermodynamics. And when you're talking about very small systems, things made of elementary particles, you have to study quantum mechanics. And this gets down to, okay, what is the basic understanding we have about how protons and electrons interact? And then we use this quantum mechanical understanding to then build up everything we know about chemistry and then proceed up that hierarchy that I just explained. As a Bachelor of Science major in physics, I'm showing here just the first year's typical courses that a physics major would have at Storrs. Now, if you come and study at Waterbury your first year, you could still meet all of these requirements. So there is a version of a calculus-based introductory physics sequence, Physics 1600. At Waterbury, we offer another version of that. It's still calculus-based physics. It's Physics 1401. And the only difference here really is that if you were up at Storrs, you would be studying physics in this class just with other physics majors. But at a smaller regional campus such as Waterbury, here you'd be taking the course not only with other physics majors, if we have some, but you would also be taking them with, for example, some engineering majors, taking 1401 and 1402. But it's basically the same content. And so this should just show you everything you can do up at Storrs. You can certainly accomplish at a regional campus before going up to Storrs, before doing a campus change to Storrs later in your academic career. So what kinds of physics degrees can you earn? I'm showing here that there are basically 5 flavors of physics degrees. There's the general Bachelor of Science degree, and that's sort of the nominal degree that you would earn as a physics major. We do offer a more applied version of that called Engineering Physics, and that's a Bachelor of Science degree. It's still a physics degree, but you would also be able to take a couple of engineering courses in there. And within that, there are 3 tracks. You may want to specialize in material science, electrical engineering, or you may want to take a couple of mechanical engineering courses. So sort of 3 tracks for the engineering physics degree. This would be very useful if you're interested not in fundamental physics, but very advanced applications of physics to new forms of engineering. For example, if you wanted to work on very new types of projects, for example, being able to tame thermonuclear fusion as a power source, well, you certainly have to have an understanding of nuclear physics, and then you have to have an understanding of one or more of these fields of engineering to actually build a nuclear fusion reactor. There is a degree in applied physics, so also a bachelor's degree. And in this area here, you would be really, again, a core physics major, but taking some additional courses that would allow you, for example, to go into an engineering field upon graduation. A 4th type of physics degree is called mathematics physics. So it's still really a physics degree. It's a very academic degree, but it emphasizes mathematics. And you'd be taking more mathematics courses in this with this degree. There are 2 tracks here, track A and track B. So if you wanted to take a bit more physics than math, you would be in track A. If you really want to emphasize the mathematics, and there is a field called mathematical physics, you'd probably want to be in track B for that bachelor's degree. The physics program at Storrs also offers a Bachelor of Arts degree. And the main difference between that and the general physics degree is that it doesn't require quite as many credits. So you might think of it as a bit of a lightweight, but still very rigorous program of study for earning credentials in physics. So what can you do with these physics degrees? Well, up at Storrs, there are lots of opportunities, for example, to get involved in your later stages of education with faculty members, perhaps doing some undergraduate research programs. And one sort of core set of topics here would be everything from astrophysics at a very large scale down to the physics of particles and fields at a very small scale. Those topics, again, well covered if you wanted to work in these fields of study by the general or the mathematics and physics undergraduate degrees. If you wanted to, again, pursue applications of physics, you could certainly move into or begin to specialize in areas such as biophysics, geophysics, medical physics, and of course, engineering. And those would be well covered by the engineering physics and the applied physics degrees. Should mention the engineering physics degree, or engineering physics BS degree, is really something that's developed and coordinated with the School of Engineering. So it's a more formal interdisciplinary program up at UConn. Applied physics is really only centered within the physics department locally at UConn, at Storrs. You may really have a love of teaching and sharing your knowledge with others. And so getting credentials, becoming a certified teacher, going into secondary education, a high school physics teacher would certainly be open to you. You may want to use your knowledge, a deep knowledge of how things work, selling technical devices to other companies or educational institutions. And of course, you may have an interest in doing science writing, becoming a science journalist. Something like a Bachelor of Arts in Physics would be excellent preparation for those fields of study. The general physics degree or the Bachelor of Arts degree would also be great. I've advised students that have gone on to careers in medicine or dentistry or the law based upon a physics degree. So for example, patent law is one obvious application of having a STEM or technical degree, in this case physics, to be able to evaluate patent applications, which can be very technical. So the physics department also offers a physics minor. So you may decide not to major in physics, but you still love the subject. And so with some credits, you could also earn a minor in physics in addition to some other major field of study. And also you may have an interest in astrophysics. So we have a number of new faculty and they are forming a core little research group up at Storrs in astrophysics. And so we have the capability now of offering enough courses so that you could earn an astrophysics minor. As an undergraduate in physics, there are many ways to enrich your study beyond just taking courses. You could do an honors program. So I have converted introductory physics courses to honors courses for certain students who expressed an interest in this, and many of them have been physics majors. And so while they're with us at Waterbury, they've gone on to study everything from very advanced mechanics, for very advanced formulations of mechanics in our introductory physics, to even a student who wanted to get a little taste of Einstein's theory of general relativity. And believe it or not, we looked into some basic aspects of that as an honors enrichment to our introductory physics class. As an undergraduate, you can also get involved with research. So there are undergraduate research opportunities, more centered up at Storrs, and you can sort of get to know faculty there. And that's a great way to kind of figure out, maybe if you're going on to graduate school, what field of physics you might want to specialize in. I'll kind of leave you with a very broad thought or very general idea. Even if you don't go on to become a practicing physicist when you graduate with a physics degree, it's going to leave you with a lot of skills and abilities that will help you no matter what you end up doing or pursuing in life. So as you can imagine, physics is excellent preparation for learning high-level quantitative analysis skills. So you can certainly bring all the power of mathematics to problems in many, many different fields of study. You'll also learn to think critically, and sort of, as physicists, we kind of learn to get to the heart of the matter, as a way of saying. So critical thinking becomes very, very important. How do you remove or peel away aspects of a problem which are not central to its solution and kind of be able to focus on what's the core what are the core concepts you really have to address in solving a problem? One aspect of critical thinking. And of course, physics is very fundamental. It covers lots of stuff, as I mentioned earlier in this presentation. It's at the foundation of all of engineering and all of the rest of the sciences. And to be able to do that, to be able to have those patterns available to you, you have to become pretty good at abstraction and generality. And it's related to what I just mentioned in terms of critical thinking, the ability to kind of abstract out the heart of a problem and then understand what you can use of that that's very general. And therefore, you might be able to see opportunities for applying the solution to one problem to many other problems because you're able to generalize and abstract. So just excellent preparation, just in the broadest possible sense for getting a good education in STEM-like subjects. If you're interested in learning a little bit more, what it's like to be a physics major and opportunities available to you, there are lots of resources on the web. One I might recommend is the Society of Physics Students, and I've got the URL over here, and you're welcome to. You're curious to learn a little bit more about what you can do with a physics degree or what physics students do, check this out. I think you'll a lot of good resources here for you to take a look at. And finally, I'll just leave you with my contact information. If you have any questions or you're interested in thinking about becoming a physics major, please send me an email address. I'm pretty good at getting back to everybody quickly, and I'd be more than happy to speak with you. I will add in closing that I also teach and advise engineering students at the Waterbury campus. So I'm also more than happy to speak with anybody who may have an interest in engineering also. Thank you very much.